Hello, I am Ethan, and I am doing quiz correction revision thingamabob videos for the initials MN. Without further ado, this is question 2, 24.1, 24.2. Solve using the addition and multiplication principles together. So, what we've got to do is we've got to bring this 4 within the brackets, first thing I see. So, we are going to get 16x minus 4 is equal to 16. Want to bring all the constants over to one side, So we're going to add 4 to both sides. 16x is equal to 20. Perfect. And then solve for x. We divide both sides by 16. We're going to get 20 over 16. And we can divide both the top and bottom by 4. So if we pull a 4 out of there, we're going to get 5 over 4. And that is our answer. Okay, so this is question 124 on quiz 24.3, 24.4. If the first and third of 3 consecutive odd integers are added, the result is 85 less than 5 times the second integer. Find the third integer. Well, let's give, just for example's sake, 3 consecutive integers are 3, 5, and 7. The relationship between each of them is that we have to add 2 to get to the next one. So say we have an unnamed integer, first integer a. To get to the next odd integer, where a is odd, I should specify, we have to add 2. And to get to the third consecutive integer, we have to add 4. So it says, reading this statement, if the first and third of the 3 consecutive integers, odd integers, this one and this one, are added, all right, so let's write that down. So a plus 4. The result is 85 less than 5 times the second integer. So that means if we have 5 times the second integer, so that's 5 times a plus 2, then we have to subtract 85 less than, subtract 81 from this side. Now, this is because when looking at our two numbers, so the first and third consecutive integers and added together and 5 times the second consecutive integer, which one's going to be bigger? And in this statement, it says that the result of these two is 85 less than 5 times this. So this is less than this. So in order for both of these to be equal, I have to subtract 81 so that this one gets knocked down a bit so that it's equal to this. If that makes any sense. Anyways, we are going to now this is just simple plug and chug. We got to solve for a. So a plus 4 is 2a plus 4. And then bring the 5 into the brackets there. 5a plus 10 minus 81. We can minus 2a from both sides. Ooh, there we go. So I'm just going to do it down here. Minus 2a from both sides, so that's 3a. And then we can simplify these two. That's going to be negative 71. Let's add 71 to both sides. So that is going to be 3a is equal to 75. Perfect. And then we solve for a, and we're going to get 25. Perfect. Now that is the a is our first consecutive integer up here. And it's asking for the third odd integer. And we figured out that the third integer is equal to a plus 4. So we just have to simply add 4 to 25, aka 29, to get our third integer. This is question 4, 26.4, 26.5. We got to factor this equation here. So first thing I would do is just to make for simplicity's sake, let's state a variable a, and let's call it z squared. So then we can rewrite this equation as 15 a squared plus 2a minus 8, something a little bit more that we're used to working with. Now, we're factoring this, so we got to whip out our brackets here. So we're looking for, if we've got two numbers in green here, they have to multiply to make positive 15. And the two numbers I've underlined, or I put the underline for an orange, have to multiply to make negative 8. And then when we FOIL, so when we multiply the green by the orange and the green by the orange, they should add up to 2, positive 2. So let's, looking at our multiple choice options, it looks like 5 and 3 are going to be the culprits. So we know that it has to be 5a and 3a. Perfect. And again, also looking at the multiple choice culprits, it's got to be 2 and negative, so it's going to be either 2 or negative 4 or 4 or negative 2. So, let's think about what I said a little bit earlier, that this times this and this times this have to add up to positive 2, excuse me. So, we can either multiply the 5 by 4, or the 5 by 2. So if we do, say we multiply the 5 by 4, that's going to be 20, and therefore we have to subtract, so that's going to be 3 times negative 2, that is going to be negative 6, but when we add these together, we only get 14. That's not low enough, so that's not correct. What if we do 5 and 2? So instead, I'm going to move this down here just so it's not on the red line. So if we did 5 and 2, that's going to be 3 and negative 4. We're going to get 10 and 12. When we add these together, we're going to get negative 2. We're close. Only thing we have to really change is let's just move the negative over to this 2 here. This becomes negative 10. Positive 12 there, and we get positive 2. So we know that the 5 has to multiply with the negative 2, and we know that the 3 has to multiply with the 4. The 3 has to multiply with the 4. So we get this equation right here, and then looking at our answers, it is going to be excuse me, I forgot. We are still in terms of a. Now, at this step that we factor it, let's just put the z back in there. So z squared plus 4, 3z squared minus 2. And then now, looking at our answers, it looks like this answer right here matches our calculations. Perfect. All right, going up here, this is question 4 of 27.1, 27.4. Add or subtract, then multiply. If a denominator has 2 or more factors other than monomials, leave it in factored form. Express the answer using the denominator of the first fraction when available. So first thing I notice, which is nice, is that both of these have common denominators, so we can write the entire thing. We can write the entire thing under one big denominator. All right, perfect. And now, express the answer. It's going to ask us to leave it in factored form, which when you ever have that in a question, it's a bit of a hint. Probably means we could factor it. So let's see if we can factor the numerator here. All right, the denominator is not going to change. So we've got our m times m. That's the only way to get m squared. So we're looking for two numbers. Let's write a little chart here. Two numbers that multiply to make 30, a positive 30, and add together to make negative 11. Now, off the top of my mind, 6 and 5, negative 6, negative 5 are pretty close culprits, except when we add these top two together, we get positive 11, but when we add these bottom two, we get negative 11, which is what we're looking for. So this has to be negative 6, negative 5, and a double check, you can just do FOIL, bring this through, just to double check, and you should get this answer. Anyways, looking at this now, we have m minus 5 in the numerator and m minus 5 in the denominator, meaning we can cancel both of these out, and we're going to be left with m minus 6, which is this answer right here. Okay, so this is question 4 of 27.3, 27.4. We've got to simplify this absolute monstrosity. First thing I would do would be, lots of these equations look factorable, so let's factor this first one. That's going to be x. We've got plus 2, plus 5. Remember, we're looking for two numbers that multiply to make 10, add together to make positive 7. In this case, 2 and 5 fit the bill. And over here is a difference of squares, and we just know with our difference of squares formula, we know that it's going to make 1 over x minus 5, x times x plus 5. Now let's tackle the denominator there. We've got x, now the same thing on the top, minus 5, plus 5, and then plus, looking for two numbers that multiply to make positive 5, add together to make negative 6. In this case, that's got to be minus 5 and that's going to be minus 5, yep, or excuse me, minus 5 and, oh no, what am I doing? Sorry, minus 5, yeah, excuse me, I'm having a moment. Minus 5 and minus 1, x minus 5, x minus 1. Perfect, yep, all right, great. So then, now, what we can do is let's look at the common denominators on the numerator and the denominator of the big overall function. So let's look at the numerator first. Both of these fractions share that x plus 5. So we want to put an x minus 5 over here. So let's multiply this side, multiply and divide this side by x minus 5. So they have a, so that's in the denominator. And let's multiply this function by x plus 2. Multiply and divide this function by x plus 2. So that's in the denominator. So they share a denominator. Perfect. I'm just going to move this actually up here a little bit. There we go. So now we've got, that's going to be x minus 5 plus x plus 2. All of that over that, all three terms, x plus 2, x plus 5, x minus 5. That's just the numerator. Let's look at the denominator now. So we've got, looks like both of the terms have a x minus 5. So we've got to multiply, divide this side by x plus 1, multiply, divide this side by x plus 5. So that means we're going to get x minus 1 plus x plus 5. All of that over. Do it on the red line just so it's a little bit easier to read. And maybe I'll make that line just a little bit smaller just so we know it is not part of the big overall fraction. And throw it underneath all these denominators. Perfect. So that's going to be x minus 5 plus 5 and x minus 1. Now perfect. And remember, at this step now, whenever we've got a fraction, what we want to do is we want to, I'm just going to move this over just so that it's easier to read. Whenever we're dividing by two fractions, I'm just going to copy paste this so I don't have to write it all out again. There we go. Oh, no, there we go. Whenever we've got two fractions, now we've got a numerator, denominator, that's the same thing as saying it's the numerator divided by the denominator. But if we remember to fractions, whenever we divide by a fraction, it just means we have to multiply by the reciprocal. So let's flip this with the power of my scratch pad. There we go. We can flip it. And now we're just multiplying the two. I will fix that just so it's easier to multiplying. So now we can just start looking and seeing what cancels. So it looks like the x minus 5 cancel, x plus 5 cancel. That looks like all for now. Let's solve the strings of operations right here. So that's going to be, ooh, come on, 2x minus 3 over, well, multiplied by x minus 1 over x plus 2. And that's going to be 2x plus 4. Perfect. And it doesn't look like we can get any farther than this. So then let's look at our answers here. Oh, looks like this has got to be our answer. I'm going to box it just because it's getting a little messy. Maybe if the box will work. There we go. Bam, perfect. All right, moving on to question 5 of 27.3, 27.4. Again, we've just simplified this not so good looking function. So first thing I would do is let's see what we can factor. So let's split up our function. The very top up here looks like a difference of squares. So that's going to be 5s minus 8t by 5s plus 8t. And we're left with st on the bottom. Looks like here, the 5 over t minus the 8 over s, we need a common denominator. So let's multiply this by s over s and multiply this by t over t. So then what we're going to get is we're going to get 5s. What was the operation? Sorry. Between there. Minus 8t over st. Perfect. Now, remember, again, this is like before, when we're dividing by two things. I'm going to cheat again, use my copy and paste feature on my scratch pad. Maybe if it wants to work. There we go. There we go. So when we're dividing, this statement up here is the same thing as saying the fraction on the top divided by the fraction on the bottom. Fraction on the top divided by the fraction on the bottom. So, again, when we're dividing by a fraction, we can simply just multiply by its reciprocal. So I'm just going to, again, cheat with my scratch pad. Copy this just so I don't have to waste too much time writing. And we can just flip it. So just bring the, oh, hi. Top to the, no, I don't want to select the entire picture. There we go. Top to the bottom, bottom to the top. And now we are multiplying. So again, let's just see what cancels out here. Looks like the st and the st cancel, and the 5s minus 8t and the 5s minus 8t cancel there. And it looks like all we're left with is the 5s plus 8t, which is going to be this answer.